evaluate log 3 base 2 times log 32 base 3. How will we do this? First of all, we start by looking at the bases. This is 2 and 3, so they're not the same. So we need to have the change of base technique or the change of base rule in order to make either one of the base the same, so we can use the normal log rules which we had discussed earlier. So I think it's best if we change this to log base 2, because 2 power 5 is equal to 32 and 32 is also here, so I feel we might be able to cancel some stuff out, so our work becomes easier. Therefore it's best we can change this to log base 2. So we can leave this the way how it is, and from the previous videos we learned that if you want to change this to the base of 2, you're going to end up with something like this: divide by log 3 base 2. So this is very similar to the law which we had derived earlier, that this becomes my x, this becomes my a, this is my b. So I've just substituted that into the formula so I can get this. In case if you're a bit worried, or in case if you're not really able to follow up, this is how the law looks like: log bx log ba. I've just translated this formula to get this, where x is 32, a is 3 and my b is 2. So this is how I get it. Now I can already see something. This is log 3 base 2, this is also log 3 base 2. They cancel out. I'm left with log 32 base 2. I said this earlier that 32 is the same as 2 power 5, so I can go ahead and directly substitute it. Now with the rules of logs, I can bring this 5 to the other side, so this becomes 5 log 2 base 2, and because these two things are the same, this becomes 5 times 1, which is equal to 5. Therefore this is equal to 5. You could have also solved this by changing this to the base of 3. It would have still worked. You would have gotten your answer 5 as 5, but I prefer using this as base 2 because I have 32 in common, and 32 is the same as 2 power 5. Solve for x where 4 to the power of x is equal to 9. How will we do this? One way on how we decided to try solve it is expressing 9 in terms of 4 power something. So for example, if I had 2 power x is equal to 32, I express 32 as 2 power something. 32 is 2 power 5, and therefore 2 power x is equal to 2 power 5, so x is equal to 5. But here we can't do it because 4 power 1 is 4, 4 power 2 is 16, 4 power 3 is 64, so there's no 9 over here. So the way on how we do this is by taking logs on both sides. Let me explain this. So suppose if I have log 4 power x is equal to log 9, and I said that log, if it's just written like this, we assume that it's log base 10. So just remember this. So log 4 power x is equal to log 9. You need to take logs on both sides in order to solve an equation like this. Now because of the rules of logs, if this is the power, we can bring this down. So x log 4 is equal to log 9. From here we can make x the subject by dividing by log 4. So x is equal to log 9 divided by log 4, and by use of the calculator you will get a value. Now before I do that, I took logs on both sides so that I was able to get a value of x. I wanted to make x the subject. Because I was not able to actually make x the subject by having 4 power x is equal to 9, I had to take logs on both sides. Therefore you take logs on both sides and then you divide so that you're able to get a value for x. So x is equal to log 9 divided by log 4, and by use of calculator you get that value as 1.58. So this question is a calculator allowed question. So just by use of calculator you get your x as 1.58, and if you want to check your answer you can do 4 power 1.58, which should be equal to 9, but since I've rounded this off to 3 significant figures, it might not be exactly 9. Your calculator value will be equal to 9. But anyways, 4 power x is equal to 9. The value of x is equal to 1.58.